was any scoring.
We'll see if that makes any sense.
All right, make any progress?
Yep.
2 ways to do it. Here's one way. Okay, so this is an example, a general formula for exponential equations. H would be the horizontal asymptote, so whatever it's approaching. So if I poured myself a cup of coffee, what would my coffee approach, temperature-wise? Room temperature. So let's say 70 degrees. So if I was modeling my temperature of my coffee, H would then be 70, because it's what it's approaching. In this case, what's it approaching?
0.
It's approaching 0, right? It's eventually going to disappear completely. So my H in this problem would be 0. So the general form for this one would be y equals AR to the T. It tells us that the half-life, we don't have an original amount. A good, easy amount we'll just say is 10. So I'm just going to, it doesn't matter, but I'm assigning 10 to the original amount. R we don't know, but we know that in 5,700 years, it will be how much? 5. I know that because 5,700 is my half-life. That's how long it takes to become half of what it is now. Okay, let's solve for R. How do I solve for R here? Log?
Sure.
So log of what?
Would be 5,700 times the log of R.
Is that right? No, we're not doing logs. How do I do it? The 5,700th root. Good. So how do I know if I use logs or roots? Very good. So if the variable is down as your base, you're going to do a root. If the variable is on the exponent, then you're going to have to do logs. We'll do logs later on in this problem. Right now, we're doing roots. Okay, so 5,700th root of 1/2. It's like 0.999 something. Definitely store that in your calculator, or you're going to be off. So store it as letter A. All right, or R. That might make sense. So now back we have my original amount. I now know what R is. T is what we're looking for. And what's my ending amount going to be in this case? If 30% has decayed, I would end up with 7, right? So now we have to solve for T. Divide by 10. So now we'd have to do logs. And 2,933 years.
That's not that long.
It's not bad. It's worth waiting for.
Oh, yeah.
Okay, so that's one way of doing it. Another way, a shorter way as far as half-lives go. We'll assign blue to this one. That will also get you 2,933 years. So this means that we're doing a half-life problem. This is the actual half-life. T is time, this is the initial amount, and the ending amount. So for half-life problems, it's a good formula to know. Divide by 10, do some log stuff, and you're good to go. Okay, so that, well, moving on to the hard-boiled egg. Questions on that?
Are we using anything new that we learned?
From last year? Or
Or just, no, from the past, like,
just
like,
this
it
stuff?
just like in the half-life problem there?
Nope.
It seems like it's all review.
Yep, that's all entire review. And this is also review, this entire problem. Okay, so 90 degree egg, put it under 18-degree water temperature, so running water on until it cools. In 5 minutes, it's 38 degrees. How much longer to get to 20 degrees? So right here, the how much longer, a few on the test or the quiz are going to forget the longer part, and they're going to solve for T, and that's going to be your answer. But the longer, if it's been 5 minutes, let's say it takes 20 minutes to get to 20 degrees. What would my answer be then?
15.
It'd be 15, forget to subtract. So whatever you get for T, subtract 5 because it's already been 5 minutes. All right, so I would use the red formula over there. What's my H? What's it approaching?
18.
18, right? It's going to become 18 degrees. All right, and a lot of times people will put A as the initial temperature or the initial amount, but in this case, A is not going to be 98. Because when T is 0, we have Y equals A plus 18. So my initial amount has to be not 98, but what?
80.
80, very good. So I have Y equals 80 R to the T plus 18. So these two will always add to be the initial amount, whatever it approaches. So if it's 98 and that's 18, you would immediately know that that's 80. Okay, so now we can evaluate it when it's 5 minutes. Temperature is 38. Subtract, divide, looks like 1/4 equals R to the 5th. Get rid of 1/4. Plug that in, you can solve from there. Okay, do you want me to finish it?
Sure.
Yes.
Really?
Yeah.
All right. So what do I have? Y equals 80 times the 5th root of 1/4, the T plus 18. And we want to know when it is 20, so that's our temperature over here. Okay, so you have to subtract 18, divide by 80. Log of that divided by the log of that.
And color good and then subtract.
And that would get us 13.31. So what's our answer?
So you subtract 5.
8.31 minutes. Okay, questions? We don't have enough time.